Today we're going to talk about light and shadows. Okay, we know this is a setup, and what we have here is a torch, a light source. Alright, we have a screen. This is a screen with a light shining on it. I have a ruler to measure the distance, and what I have here is a small little box as my object right in the center. Now we can see that when I switch on the torch, right, what we can see, there is a patch of brightness at the screen, right? It's bright. What happens when I put a matchbox right in the center? You can see that on the screen there is now a little patch of darkness, and we call this a shadow. Now why is shadow formed? And that's because the light, as we know, light travels in a straight line. That's because light travels in a straight line, the light cannot pass through this box. So because the light is being blocked by this box, and that's why this part of the screen here doesn't receive any light, and a patch of shadow will be formed. Now what happens when you move the matchbox, the object, closer to the screen? Let's see what happens. What happens to the shadow? Can you see that the shadow has now become smaller? Alright, so as we move the object closer to the screen, the object will become smaller. Let's see what happens when I move the object closer to the torch. Now as I move the object closer to the torch, the shadow has now become bigger, much bigger. Okay, I'll explain why this is so in a moment, but basically what we know is the object, alright, as we move the object closer to the screen, the shadow becomes smaller. Alright, as we move the object closer to the light source, which is in this case is the bulb, the shadow becomes bigger. Now what happens instead of moving object, let's move the torch. Okay, if I move the torch closer to the object, what do you think will happen? Let's take a look. Now look at the shadow. Can you see that the shadow has now become much bigger? Alright, the shadow of the object has now become much bigger. As I move the torch nearer to the object, and now I'm going to move the torch further away from the object. Okay, and you can see that the shadow has now become smaller. So once again, if I move the torch, the light source nearer to the object, the shadow becomes bigger. I move the light source further away from the object, the shadow becomes smaller. Okay, now next, how about the screen? Instead of moving the object or the torch, can I move the screen instead? Now let's see. If I move the screen closer to the object, what happens to the shadow? You see the shadow has now become smaller. What happens if I move the screen further away from the object? Can you see that now the object has become bigger? Okay, so once again, screen closer to the object. Okay, the shadow becomes smaller. Screen further away from the object, the shadow becomes bigger. Okay, so that's it for now. I shall explain to you why this is. Okay, let's now attempt to explain why that shadow is formed on the screen and how it's being formed. Why does the shadow sometimes is bigger, why sometimes the shadow is smaller? Now the basic concept, the basic property of light that we have learned is light travels in a straight line, which means that light can be blocked if something is in its way because it cannot bend around. Okay, so because light travels in a straight line, and if we look at our setup, this is our setup. The torch is here, object is in between the torch and the screen, and this is the screen. And this portion here is called the distance between the torch and the object. This part here we call the distance between the object and the screen. Now what happens when we switch on the torch and the object is here? Now let's try moving the object. Okay, let's try changing the distance between the torch and the object, and the distance between the object and the screen. Now this is when the light torch is on. Can you notice that I use straight lines with arrows, straight line arrows to represent light rays? Why do you think I use straight lines? Yes, because light travels in a straight line, right? So my straight lines actually represent the light rays from the torchlight shining onto the screen. So you can see that this part of the screen where the light from the torch can shine onto the screen, this part of the screen will be bright. But this part of the screen, the light is being blocked by this object over here. As such, there will be a patch of darkness here where the light cannot reach on the screen, and this is what we call a shadow. Now what happens if we move the object? If you move the object closer to the screen, can you see now it has blocked less light rays? Now just now, we have blocked 3 light rays. As we move the object closer to the screen, we now block less light rays, and as a result, the shadow is smaller. Alright? Now what happens if we bring the object closer to the torch instead? If we bring the object closer to the torch, to the light source, can you see that now we are blocking even more light rays? As such, less light is able to reach the screen, and there's even a bigger patch of darkness here, and then a bigger shadow here because more light is being blocked. Alright, so let's take a look. Okay, this is when the object is near the screen. Alright, the shadow is small because it blocked only 2 light rays. Closer to the torch, the shadow has now become bigger because it blocked more light rays now, and if it's even closer, it blocked even more light rays, the shadow is even bigger. Alright, and notice that as we move the object, the distance between the torch and object and the distance between the object and the screen also changes. Alright, the distance changes. And notice that distance changes. Okay, the distance changes. Alright. Okay, now let's try, instead of moving the object, we move the torch, which is we change the distance between the torch and the object. Now, this is where the torch is. Now let's see what happens if we move the torch. Now as we move the torch closer to the object, we didn't change the distance between the object and the screen, we just changed this part of it, the distance between torch and object. You see that more light rays are being blocked by the object. That's why the shadow is now become bigger compared to the previous one. Now previously when the torch is over here, there's a long distance between the torch and object. The object only blocked 3 light rays. Alright, this is a smaller shadow, but as we move the torch nearer, it blocked even more light rays, and the shadow is now bigger. So that's the distance between the torch and object. Now as it becomes shorter, as it decreases, the shadow now becomes bigger because it blocked more light rays. Now how about instead of moving a torch and an object, we move the screen, which is we change the distance between screen and object. Now imagine the screen is here, object is here, torch is here, and we cast a shadow onto the screen. What happens if we move the screen further back? Okay, as we move the screen further back, the number of light rays blocked is still the same, but because the distance is now longer, okay, the shadow cast is now much bigger. Okay, so we didn't change the distance between the torch and the object, we just changed this part, the distance between object and the screen. Let's take a look again. The screen closer, this is the shadow. Screen's further, the shadow is now bigger. Alright, so I hope that you have now understood the relationship between the distances, the object between the object and the torch, and the distance between the object and the screen, and the size of the shadow. Alright, thank you.